Great. My name is Bernhard Hopfenmüller. I'm working for CROZ. I've been working in this field of DevOps and SRE for roughly 10 years. And I will tell you more about CROZ in a second. The thing we want to start first is to give you a short survey so we can better understand who you are and what you are doing here. My colleague will just pop up a quick first server in a second. Don't worry, it's not long. Waiting for the server to pop up. Great. We have three short questions prepared for you. The first being, we want to understand if you actually are a beginner to Terraform or if you have been using it. So if you're a total beginner, if you're a bit advanced user, or if you have been a long time user, even a creator of providers, modules, etc., pp. Then we want to understand what you're currently using. So if you're using a community version of Terraform or something similar, if you are maybe already using HTTP Terraform in whatever sense, or if you're maybe on the enterprise side and running Terraform Enterprise on your own premises. And last but not least, we want to understand what of the features that a HTTP offering or enterprise offering might offer you. So what's most interested for you? Having a shared state and safe collaboration, more compliance direction, RBAC features on-prem, or something looking more towards the future in terms of no-code deployments or similar self-service feature things. We will leave that up for another 10 seconds, I guess. And then thank you so much. I think we can enter poll. And I will share my screen and get started with our presentation. Share and so need to move my windows out of the way. There we go. So we're talking about IBM HashiCorp Terraform today, and we want to understand mainly how you would scale Terraform in a real world. As I said, my name is Bernhard Hopfenmüller. I'm from Munich, and we have a beautiful autumn day here today. So I hope wherever you are, the weather is similar for you. What's the motivation behind all of this? As an example, for understanding what this is, we will go back to the year 2023 and we will look at one of those things that seem to happen more frequently these days, a beautiful outage of something. In that very specific case, we're talking about the GitLab.com outage that happened on the 7th of June. And I want to really emphasize here that I'm not trying to blame GitLab, quite the contrary. I want to applaud GitLab for doing such beautiful post-mortems and being very open about what went wrong and how they fixed it, so we can all get some learnings out of it. Not everybody is doing it in that very beautiful way. What happened? Just to give you a short overview, GitLab tried to put a change in their production database, and since they were very well prepared, they prepared a change doing it with Terraform 3 weeks prior. And the problem was that in those 3 weeks, while they created the new code for their production upgrade, the environment drifted, meaning the actual production environment looked differently than they thought it will look, right? And when they then tried to apply this new state to the out of sync environment, things went kaboom and everything didn't work anymore for a couple of hours. No huge outage. I mean, we've had worse outages over the years, but it's a very nice example to understand that this out of sync being and the environmental drift is something you really need to take care of when you're handling Terraform for your production issues. Who are we? When I say we are a Croatian German BizTech consulting company. And while the word BizTech might sound confusing at first, it's actually very simple to explain. We are trying to align technical solutions with business requirements to building our business goals to create a beautiful solution that goes from end to end, not only looking at the business side, but also not only looking on the technical side. We are doing that, as I said, with a Croatian German company. And the way we approach this BizTech thing is a 3-pillar based cycle, right? So we start in this yellow field here that says strategic and strategy and service design, basically understanding the business side of what's going wrong or where you need something to be done. then we go on to our engineering side and actually implement something. And we have a big variety of things we're doing, starting from really legacy, you might say, mainframe services, going up to the modern things with AI, of course, cloud engineering and classical software engineering as well. And once we have the solution engineered, we also have a team or a bunch of teams that do actually operational services. So we help you also to run your production, your solution then in production. And then, of course, at some point, we are back at the beginning trying to understand what's the next thing we want to do. We have around 400 people in our company, and we've been dealing with around 1,500 projects over the last 20 years since we exist. And some people also say that another USP of us is the mixture of Croatian engineering and German humor. And of course, we are not doing this very alone. As you might understand from today's webinar, for example, we are partnering with big companies and small companies, but here we are trying really to build on the new technologies that trusted partners build and deliver with those the best solutions to our customers, right? We are IBM Gold partner, we are Red Hat Premier partner, and we have a bunch of other partners that fit in the various technical solutions where we need them. So let's put that part aside and actually focus on what we're talking here today, right? We're talking about Terraform. And maybe just to revisit Terraform for all of those who never heard of Terraform before, or those for them it's been quite a while. What is Terraform? Terraform actually helps you to write infrastructure as code, right? And if we have a very simple microservice, as you see on the bottom here in AWS, that might consist of actual code that's running in a containerized environment somehow with a load balancer in front. We have a S3 bucket to store some artifacts. We have a content delivery network that actually might serve those static contents, and we have a database in the backend. And all of this code is somehow dependent on each other, right? We cannot reach the application without a load balancer in front. The content delivery network cannot provide any files without the S3 in the backend. And of course, without having a database, everything that our application is doing that's not supposed to be temporarily, we need a database. So we have dependencies in our infrastructure. And Terraform does not only allow us to write down all those resources we need in the configuration we want them to have in code, but also helps us to calculate the dependencies between those things. So, as an example, if I wanted to display an S3 bucket, that would be the very simple written statement that I would need in my HCL, so the Terraform language, to describe how that would look like. Now, if I was to take this code that I've written down described all the components, so I described the database, the S3, the load balancer, etc. pp. I wrote all that down in code. Now I want to get that actually into the real world. So right, I have my described world, I have my real world. And the most important thing from going from infrastructure as code to actual running code, we have three basic Terraform commands. The first one being refresh. And the refresh command is doing nothing else but saying, hey, how about you get me the real world described into my state file? So into a file that describes what's actually currently going on. That's why it's called state file. So that's the first thing I would run. And the refresh would in this case say, hey, listen, your real world is empty. You have described your world, which is beautiful, but you have not deployed anything. So the next thing I would do is run the Terraform plan command, right? And the Terraform plan command basically says, listen, Terraform, can you basically tell me how I would get from the described world to the real world using the state file and writing that into my plan? That would be the way from going from my described world into the real world. And the beauty here is that Terraform will calculate for me the dependencies between all those resources I do have. So I do not need to take care of, do I need to deploy first the application or first the load balancer or maybe first the S3? So Terraform is basically calculating that graph for me. And once I have the plan and I know that this will work, I can run my Terraform apply command. That will actually say, okay, Terraform, please go from the described world to the real world using the plan and update afterwards the state file, right? So the state file now describes what's actually really in my living real world, the case. And that works quite well, not only for day 0, but also for day n, right? On day 0, I describe my world how I want it to be and I applied. What about at day n, right? Things might change. For example, I might want to get rid of some components as I'm showing here in my described world, or I want to add a new component, like let's say Kubernetes cluster or something like that. So the beauty here is that I do not need really to make sure that I use some other mechanism to go on day n to a new change, but I can do nothing but change the description of my current code, run again, Terraform, refresh, plan, and apply, and I will get that changes incorporated into my real world. Beautiful, right? Theoretically, very beautiful. And if I'm living in a lonesome world, this is pretty easy to use, right? There's Alice. Alice writes down her infrastructure's code. Alice applies her infrastructure's code to the cloud, and Alice has a local state file. So she can do on her machine everything that she wants, and she will have the state that she wants. And now we are at the works on my machine world, but we might introduce Bob also to the thing. And this is something we could still do, right? Alice and Bob could still work on their, let's say, GitHub repository together, describe the infrastructure's code, apply it to the cloud. And then you can do things like having a central state file, for example, having it in S3. You need to take care of yourself that you encrypt it, and you need to make sure that your state file is locked once Alice or Bob is actually trying to apply something, right? Because if Alice and Bob at the same time try to apply something that is even contradicting, that will lead into errors. So if everybody knows what they're doing, and if you take care of state file encryption and state file locking, you can work that way. But what about if now Tom enters the stage? Tom is one of those developers, right? I don't want to blame developers here, or I don't want to serve any prejudices, but Alice and Bob are very seasoned DevOps SRE people, right? And Tom is a developer. He's a great developer, but Tom does not know any Terraform. So how can Tom now deploy his code into this cloud or his resources that he needs? And that's the situation where we actually get into trouble. Because this model here we have with a central state file and two people using it, we don't have any governance. We don't have any role-based access control. We also don't really have any standardization or any auditing. And we also do not have any policies that forbids Tom, for example, to do anything we wanted to do. Also, we don't really have that drift detection thing here anymore, right? That I mentioned in the very beginning of this webinar with the outage at GitLab. And last but not least, we don't necessarily have cost control here in place. So if Tom is asking for 5 H200s to be deployed in the cloud because he wants to do some of his AI stuff, there is not out of the box anything in place that will forbid Tom to deploy that and do that. So we need to look really into how we come from a model where we use Terraform to a model where we use Terraform in a controlled way, right? So to summarize it, at scale, the challenge isn't really to write Terraform code, which can be challenging as well. Don't underestimate that. But the real challenge is actually running Terraform safely across teams. HashiCorp has something they call their HashiCorp Cloud Maturity Model. And that model basically consists of 3 stages. The first stage is the adopting stage. And that means, okay, there is, for example, Terraform. Why don't we use that? And that would mean that selected people start writing Terraform code. For example, that EKS deployment that was always a hassle in the last time, they would create code for that they even would share among each other, but there would be single people that would use it. So we have individual automation. The second stage would be that we somehow establish policies and shared practices, meaning we are not only allowing in the long term developers to use that, but we are one step further. We are trying to forbid the usage of things. We are trying to implement security specials. We are trying to deploy always in the same way, right? As the name says, we're trying to put a standard on it. And the third stage and the last stage then is actually the bright, shining future, meaning we want to scale the whole thing. So in the ideal world, we want to achieve a governed, automated self-service infrastructure. Pretty heavy words, right? It would mean in the end, actually, that Tom can now click on something and he will get something out of the box without actually needing to know very much about Terraform, but still being able to use all those governed shared policies and practices. And if we look at features that Terraform is offering, we can actually map those to those stages, right? This is not a comprehensive list of features that HashiCorp Terraform versions offer, but it's some of them, and I want to go over them. So when we are in the adopting stage, for example, we are at a world where we want to compose Terraform content, right? Meaning for this HCP Terraform, which I will talk in a second about what it actually is, we have execution environments where we run our code, meaning we are not running the code anymore locally on our machines, but we have some platform where everybody can actually execute their code, meaning we don't have problems with who's locking the state file. We don't have the problem who is allowed even to work there. We have one place where Terraform is run from. We have a management of workspaces. We have the option to secure variables, very secure, right? That's something I actually didn't mention before at all. But if you want to deploy a database, you might want to you might need credentials to access the database at some point. Or even if you want to do something in AWS, right? You have to have your AWS credentials somewhere, and you probably don't want to have them in a GitHub repository. And I already included that part. It's not only composing stuff, it's also collaborating on stuff, right? So we have the centralized remote state storage. We have rail-based access control with project roles and workspaces, so we can keep people in the places where they should be and make sure that nobody is doing something he's not supposed to do. In the next stage, when we're standardized, we have two main things here. We have the enforcing of policies and the publish and discover part. Let's start with the bottom one. Publish and discover means nothing else but, hey, how about we create our own place where we create secure Terraform content for my company and share that for everybody in the company to be reused, right? And that would be enabled by the private module registry that comes with HCP Terraform. We can version the modules we put in there. And we can even create Terraform stacks, that rather new feature that would basically allow you to manage the whole lifecycle of different deployments in that matter. And we have the other part where we prevent things from going very badly. So we can use OPA or Sentinel policies, meaning we can, for example, forbid people to deploy those very costly things, or we can prevent people to create virtual machines on the internet that have publicly accessible ports, etc. pp. And we can integrate security tooling. For example, if we also have HashiCorp Vault, I don't know if you were in the webinar of last week where we spoke about that, or other tooling, you could make sure to plug that in here and use it, and also force basically your users to use that. And at the third part, where we scale the thing out, we have two things. The first one being able to observe and respond. So we can do continuous validation and drift detection. We can make sure that the infrastructure we set up is healthy and up and running. And we can make sure that the infrastructure is actually looking as it's supposed to look. We can do deployment checks pre and post. We can have external notifications. For example, if we detect a drift, so we can quickly react to drifts. And we have audit trails, right? We can look at who did when what. It's very important in terms of governance and regulations. And the golden crown at the end, right? We can enable self-service. So we can do something that's called no-code provisioning. I will show that in a second. But to spoil it already, it means nothing but basically offering via the private module registry, you have a module that doesn't need any input besides parameters you can type in a GUI. So people can, with entering the name of a virtual machine, just click their virtual machine by themselves. We can summarize it again, basically standardize our whole application delivery, and we can do things like estimating the costs of the whole thing before we even deploy it. right? So we also filled this enabled self-service thing in our third stage. Now I spoke about HashiCorp platform and enterprise, and what does that all even mean? Basically, there is three things, right? There's Terraform Essentials or Standard. That's in HCP, the SaaS offering that gives you the thing to start off. It's enterprise-grade collaboration and automation with some features, but not all features, of course, on top. Then you have Terraform Premium, which is basically the top tier of that SaaS offering, and that has some advanced capabilities and governance things. For example, you can hold your own key, so you can do your own detection, your own encryption with your own security credentials of your state file. You have a higher level of concurrency when you want to run several things at the same time in several different workspaces. You can have private policy enforcement, you can revoke modules, and you can set up connections with agents to your own private version control systems. Say you have your infrastructure on-prem and you have one server that's actually allowed to talk on-prem via DMZ or whatever, you could plug that onto your Terraform Premium and make sure that's only that connection is used to communicate between your on-prem environment and your HCP SaaS offering. Or if you are in a very regulated or air-gapped environment, you can use Terraform Enterprise, which is basically Terraform Premium, but on-prem, right? So you would install this whole platform on your own premises, and you would not need to deal with the cloud offering. If we look now how a GitOps workflow with HTTP Terraform would look like, that's basically the end-to-end workflow, right? We have a developer that's creating a commit to some Terraform code. He's checking that into his version control system. And once my version control system is plugged into my Terraform, that would trigger a run. Then I would apply the Sentinel and cost policies if there are any. If I set up approval, somebody that has approval would need to click on apply, and then the whole thing would be deployed. And the state of that run would be stored centrally, and every action that happened was logged and audible, right? So I can pretty easily integrate that HTTP Terraform into my end-to-end GitOps workflow. It would be not much different from using or from writing code together, right? Where we also have the same GitOps pull request features with CI/CD pipelines in place. Let's look at an example that I want to demo here, right? We have Alice, and Alice wants to deploy some application into Lambda. So basically, we have some JavaScript code that does nothing but saying hello world. We zip that hello world content into a zip file, put it in S3. Then we put a Lambda function that's actually using that zip file to serve that JavaScript code. And we put API gateway in AWS in front of it. So when we serve the endpoint, we actually, and curl it later, we get basically hello world back. If you want to look at the example, I more or less took this publicly available code here and modified it a tiny bit so you can have a look yourself. So let me switch my screen so I can show you what I'm doing here. You should be able to see my browser now. And I will start here in my code repository, right? I have here my Terraform code. I will not go over the complete details. As I said, there is this components of S3, Lambda, and the gateway, basically. And I need to do some EIM to make sure that actually the correct permissions are here. And I want to trigger a run, and I will do that just by now changing something in my code. Let's, for example, consider that I will go into my Lambda code here and just change the name of my function name to, let's say, hello world with two O's. And then I will just commit those changes. For the sake of the quickness here, I will just do that now here inline in the main branch. That's of course not the best practices, and that's also not how I would do it on prod, but I think that speaks for itself. So let's say change Lambda name and commit the change. And now we switch over to my HCP Terraform, where I basically show you the starting screen. So we have here in this Terraform space several projects. Could have several projects. In my case, I have one project set up. And inside that default project, I have one workspace, right? And that's called Terraform Demo. And as you can see already, it's in a planning phase. So if I click here, I can show you that this now is obviously connected to my GitHub repository, right? Because I have here my beautiful picture showing up and the Git commit that I did, and that triggered a run. And I can see here when I click on it, what's happening, right? So what we can see here is in the planning phase. So first we had the refresh phase. Now we have the planning phase, and the planning phase is telling me that it will create all those beautiful AWS resources. Then we have some part that I will go into a bit more details later, where we check some policies. We have some cost estimation block, and we are actually now in the apply phase, right, where we are creating all those resources that I requested. While this is still running, I can show you also that when I click in the overview, I can see under runs, I can see all the runs that I did over the past couple of days. I don't know. And you can see there were a bunch of errors, but you can also see with every run, how was it triggered and who triggered it, which is important in terms of understanding what's going on. I can also see for each and every run I did the state, right? So if I click here on that current thing now, I can actually see the current state that I have here done. And I can also see here what it would change, right? So that is very good for debugging purposes. I have variables set that I could look into here. For example, here I have, as you can see, my AWS credentials stored. They're sensitive, so you can't see them now, but I can implement those here. And at the health section, we will look in a second, but that's basically the overview you need for now. And we can see now that was applied, right? So if I click here and scroll to the bottom, I can see that apply was finished. And I actually did get from the output some resource. So in that case, an URL that I can use. And now let me share another screen. Wait, no, let's do it differently. I will first switch into my AWS account and show you that it was actually created. Yep. Sorry. Yep. I think I'm in the wrong zone. Yeah, here. You see I have one Lambda function, and if I click here, you can see that I have now this beautiful hello world function with two O's. And if we wanted to, we could now go into detail and look here at the JavaScript code that, like I said before, is not very spectacular. It's basically only returning hello world when it gets called. So let's go ahead and switch over for a second to a terminal. And let's call that function just to, yeah, exactly, just to show you that it's actually working, right? So I successfully deployed my Lambda function behind a gateway, and I can use it. So that works, right? That's beautiful. So now I spoke before about what happens with drift detection. Well, let's show it. Let's just go ahead, be brutal, and delete that manually, that function that I deployed. What will happen now? Well, for now, nothing will happen, right? Because we're this, when we go to health and look at the health, the drift detection is running every 5 minutes. Unless I trigger it manually. And that's something I want to do now, just to show you that it actually does detect the drift. And I can do that once the Terraform page is loading again, which is beautiful that it's not doing that now. Okay, there we go. So we have no drift detected, but I will just start a health assessment manually and show you that actually it would detect the drift eventually automatically. And the health assessment is actually when we take it exactly nothing but another run that will go ahead and check that. Let's see if it's in process. Okay, let's wait a second and look at that once it's there. For the second part of this demonstration, I want to show you those policies I was speaking about, right? So as I said before, we can prevent people from doing things they're maybe not supposed to do, and I will do that. Okay, thank you. I've been told you're seeing the wrong window. Great. Let me switch over to my screen again. Thanks for pointing that out, guys. There we go. Great. Okay, now I can repeat what I said, and you actually see it in the meantime also. So what I did is I manually deleted the function that I deployed, right? You can still see here the success message that I deleted the hello world function. You can see there is no more function anymore here. And when I clicked in my Terraform projects in the health section and in the drift, I can actually see that there is a drift, right? And the drift is telling me, hey, your function is gone. So there's actually two things I could do. I could either accept the drift changes, meaning I could take the changes I did into my code and push that newly, or I could start a new run basically and didn't want to click here and remove that drift, right? Because the state is still there, saved. And if I just do a new run from my UI, it would bring up that Lambda function again as the plan dictates that there should be a Lambda function in my AWS deployed. So while we wait for that to happen, now you can see it, we're doing a new run. I wanted to talk about that policy thing I was speaking about before. So policies are basically written in code things that are allowed or should not be allowed. For example, I don't want to allow a user to, as I said before, deploy a virtual machine that has public available ports or public available IP addresses. And then I would write in code a policy that would prevent that or would check if my code does that. And already on the planning and applying phase, tell me here under my policies that this is not supposed to happen and stop the run right there. I will show you in a second how the code is written. For now, I want to show you here that my plan now sees, okay, we need to change two things, right? We need to make sure that the function is up and running again, and we're doing that here. And then if we click here and update here, we will see that the function is back in place. So the drift was successfully mitigated. So looking at those policies, I have created a policy here, for example, that's called JS version, right? And from the description, you can see it says we don't want any JSON version below 20 to be used. Let's look into the code. It's very uncomplicated to actually understand what it's doing. So what this thing is doing while we prepare the run is it looks at the plan that we created from our Terraform plan statement. It will look at all the Lambda functions that are part of the plan, and then it will go over a list of allowed runtimes that I created previously and make sure that all the Lambda function runtime parameters are actually in that list, right? So we, for example, won't allow any Node.js that's below version 20. Why? Well, because it's out of life and not supported anymore. So we don't want our users to deploy any unsecure code, so to say. And if that works, everything is fine. And if that doesn't work, well, we will get an error and we cannot deploy then afterwards. And you can see, for example, I chose for that a hard mandatory enforcement behavior, meaning that run would actually fail at that point. To demonstrate that, I created in my code repository a pull request where you can see that the change I did was here, to change the runtime of my Java down to Node.js 18. As you can see already, quite conveniently, if I create my code repository to my HTTP Terraform, you can see that this is also running dry run plannings for pull requests, right? So if I click here on that link that was shown here, I can see that this planning failed here, right? Because it's telling me, no, you're not allowed. Policy evaluation failed. You're not allowed to deploy a JavaScript that's in a lower Java version. it would look like this, right? We can see here, main rule that blah, blah, blah. Lambda runtime must be one of the allowed versions, and Lambda JavaScript 18 is not among those. So we can still do the funds and merge that. Let's merge it. And what we will then see is that we actually get a new run. And that run will fail, as we saw already before, because the policy is violated. While we wait for that to happen, last part of the demonstration, I want to show you that shining bright path into the future where we can enable developers or any other person that is really not into Terraform to still use our governed standardized Terraform infrastructure and create things without getting into the need of tiny details in HCL language. See, right? It failed. So we are not allowed to run that Java 18 thing. How would I do that? So if I'm a user, I can always go into the registry, right? We have as I said before, we have a registry that basically contains all the resources for my Terraform world that are standardized and should be publicly available for everybody in my company. And I created here, for example, also you can find the code upstream in the example. It's nothing too fancy, but it's creating a Postgre database in AWS, right? And it's doing that in no code style. So just to show you how the code look like, maybe that's kind of interesting. Let me here. Let me jump into the repository and very quickly show you that this is basically one long main TF file, and it's creating a VPC, and it's creating some access credentials, and then it's actually creating here a AWS database instance of type Postgres 16 and putting a random password onto it, right? So nothing too complicated. And when I uploaded that code into my registry, I selected that I want this to be no code ready. Meaning, if I click on that thing as a user, I can click on provision workspace and saying, hey, I want my own deployment of a database using that no code thing. The only thing I need to do here is give a database name. So let's call it testdb and some username. And since my name is Bernhard, I will say here Bernhard H. I will click on next. I will give that a deployment namespace. Let's say Bernhard H DB deployment. And then I will create a workspace. I will select the default project and I will create a workspace. And what happens now is that this deployment will create a new workspace in my chosen project, and it will apply the module code into that project. Right, into that workspace, sorry. And doing that, I can use it in the same way as any other workspace. I have here now triggered a deployment for our code, and you can see that's all the things I would deploy to have actually then my database instance up and running in place. Planning should be done, policies passed, cost estimation passed, and now we are actually applying it. It will take a bit longer, but it will actually get there. So I will not wait now until this is fully deployed. But I think you get the idea, right? Using or enabling people to use the private registry content with no code features allows pretty much anybody that's able to use a GUI and fill in 2 fields or 3 fields to use that pre-prepared code by me and even have all the policies that I've defined before have in place for that code, right? So that's pretty neat, actually, pretty neat feature. Great. Let's jump back into the presentation that we have here. And let's continue the slideshow. Right. So we looked at how to manage that workflow, right? We created that Lambda function with a 3 in the gateway. We looked at the policy enforcement. So I demonstrated to you that the policy I wrote prevented the usage of the out-of-life Lambda runtime. You could basically write policies for almost anything you wanted. So your imagination is the limit. So to say, you could also use cost features, for example. So you can say up to a certain amount, you would then stop allowing it, whatever you want to, right? Public ports is a common thing. You could even go ahead and take your sys benchmarks that you wanted to, or your stick or your Nodora or whatever you want to have, code that in Sentinel policies, and then basically use that to prevent people from doing shady things in their deployments. And last but not least, I also showed you the no-code features, right? Where you can create specific resources from pre-created modules without the need to actually go into code for people. So you can use that via the GUI. If we now do revisit the maturity model and you yourself look at what you are doing currently with Terraform in your company, you might wonder, where am I on this model, right? Am I adopting? Am I standardizing? Am I already scaling? And well, the answer is probably not so straight ahead, right? Just think of a company where some people already adopted it in one department. However, the third department is already building self-service infrastructure around it. So it's not very easy to determine all the time where I am actually on that model. And the even more interesting point is maybe this model doesn't even apply for you, right? Because the world is never so simple as to say have three distinct stages where we are living in. So there is a pretty good chance this model will not apply for each and everybody. And to quote George Box, a famous British mathematician and statistic person, he said, essentially all models are wrong, but some are useful. The statement goes a bit longer, but that's the gist of it, saying, okay, we can look at models and we can understand maybe what useful things we can take out of models, even though never any model will really map the world to the reality where it is, right? So the more interesting question is probably not for you on that cloud maturity model, where you are, but where you want to get to. So what's the thing you really want to achieve? Do you want to achieve standardization currently? Do you want to achieve currently already self-service platform? Or do you want your people in-house to understand how cool Terraform is and maybe only write some Terraform stuff to get started ahead? Especially if you want to get to the later part where you want to have broad acceptance of people in-house that actually do use your Terraform thing. The tricky thing is to make people accept what you're doing, right? And when do people accept things? Not if things are built the way you like it, but probably the way they can not only like it, but also they can know how to understand it and operate it. And that's a paradigm we very often see. So if you want to get your people to adopt a tool like that, you need to engineer that. You cannot assume that it will actually happen only because it's a cool tool, but actually because you made the effort to understand what is needed and who needs what when, right? And that's something we at CROZ usually do when we go into that golden bright way and start building self-service platforms or effective digital platforms that we call it. We want to help people understand that they should do the right thing. They should not do the thing right, but do the right thing for themselves, in that case, for you. And we usually do that by getting people first to understand why they want to do something and then find the right things to do, create a mapping between what is needed, what's the business value of that, what's the actual technical solution behind it, create a roadmap, implement that in terms of a POV or POC, and then, very important, do a retrospective, be it a user survey of the people that should adopt that platform or somehow else, and then roll it out and then repeat the process, right? So it's never done after one cycle of those, but it's a long-term thing. And if you want to build something like a platform in-house, regardless now if you want to use the HashiCorp Waypoint tooling or something like Backstage or Red Hat Developer Hub, the important thing is that you do understand adopting something like that will give you a product mentality in your house anymore and not just we are using one tool. But that's something on the side. I will end now at this point and open the room for discussion and for questions from your side. So let me stop sharing my screen and look at the chat if I see if we have any questions, but I don't see any yet. So if you do have any questions, please feel free to type them now into the chat so I can see them and I will very gladly answer them. While I will give you a second to think about potential questions you have, I would ask my colleague to bring up the other survey we still have created. Thank you very much. That would basically say, hey, after you heard today about this HCP Terraform, what's the things you would first look into, right? Is it maybe the policy thing? Is it maybe the drift thing? Is it role-based access control? Is it central state storage? What's the thing that's something you would take as a next big thing? And the second question is, if we were to do a future webinar about Terraform, what's something that would be of most interest for you? So would you like to hear maybe about new hot things in Terraform like actions or Terraform stacks? Or would you like to go into more depth what a module is, how you would write modules, um, how you would communicate with external sources? So feel free to type in whatever you want to. I think we will give it another 10 or 15 seconds. Okay, thank you very much. Then I think we can also slowly end that thing. And let me share again my screen. I do not see any questions so far. So let me take the chance and um, provide you with the information that this IBM webinar series we are doing will continue next week with in my personal opinion, very interesting topic of quantum safety, right? We will, Miro will give you some insights in what quantum computing security really is and why this is a hot topic, even though it's a bit underrepresented currently. We will talk about API management on 20th of November, and Julia will conclude the series finally with something about IBM Orchestrate, so more towards the AI direction. I still did not see any questions, so please let me also inform you that if you have in the aftermath any questions, please feel free to reach out either directly to CROZ or directly to me. We will happily provide you with any answers you want in that regards. And I will take one last look at the chat, and I'm not seeing any questions. Well, and then with that, I will stop the sharing. And thank you very much for your attention and wish you a pleasant day still. And hope to see you soon. Thank you so much. We will stop the recording now as well. Bye bye.